Welcome to the NASA Earthdata Series MODIS Subsetting and Visualization Tool webinar. This is your host, Jennifer Brennan. While everybody is logging in here, we do have a couple of polls. As I mentioned at the bottom of the page, we'd appreciate you answering if you could take a minute. There is not a submit button with the polls, with the exception of a short answer poll at the end of the webinar. There is a submit button for that one. So once you've selected your answer, your vote has been registered. I have 2 o'clock, a couple minutes after 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. So good morning, afternoon, or evening, depending upon where you're joining us from. As I said, I'm Jennifer. I'm the outreach lead for the NASA Earth Science Data and Information System project here at Goddard Space Flight Center. I do want to go over a couple of housekeeping items related to the webinar. Currently, I have the entire the participants muted because we are experiencing some feedback, and it might be from an international caller. If you have a technical question, please feel free to enter it into the question and answer pod in the lower right-hand corner of your screen. Okay. Audio is not going to be broadcast through the computers for this particular webinar. You will only be able to hear the audio through the telecom at this point. Okay, so once you've dialed in, mute your telephone speakers, although I do have you muted. If you do unmute yourself and you can hear feedback, then please go ahead and mute. Again, *6 is to self-mute and unmute. The webinar is going to be recorded. I will send a link to the recording out to the participants and also to those who are unable to attend the 2 webinars, the one today and also tomorrow. The recordings will also be posted to our Earthdata Adobe Connect catalog, which will be presented to you at the end, the link to that catalog. The webinar is 1 hour long. There will be 45 minutes for the presentation and demos and 15 minutes for questions. Typically, I will extend the question and answer period if need be for an additional 15 minutes. So for those of you who need to get off the webinar at 3 o'clock Eastern Time, please feel free, although we will stay on if needed to address any questions for an additional 15 minutes. All question and answers will be recorded by way of the question and answer pod, again here, down at in the bottom right-hand corner of your screen. Okay, so you'll have an opportunity to ask your questions throughout by using that question and answer pod. It works like chat. If you have a question, go ahead and type it in so we capture your questions. However, the speakers will not address any questions until the end of the webinar. So we'll address the questions verbally at the end. Due to the size of this webinar, I have disabled the raising hand function. Okay, so just before we move on to the question and answer period at the end of the webinar, we will have about 5 minutes for participants to take a break and also to complete a couple of polls we've designed to give us feedback on today's webinar, with the hope that we will improve the webinars in the future, and it also helps us to tailor content for future webinars. Okay, so why don't we move on to the agenda here. Pull that up for you. Okay. So the first 20 minutes of the webinar today will provide you with an overview of the Oak Ridge National Laboratory Data Center and also the MODIS Global Tool. The second half of the webinar is dedicated to a demonstration of the tool and the web services associated with the MODIS Global Tool. We will then end with our polls and a question and answer period. I'd like to now turn it over to our first speaker, Tammy Beatty, who is the Deputy Manager at the Oak Ridge National Laboratory DAAC. Tammy?
Okay, so everyone can hear me now. I'll start from the top and give you just a little bit of information about ORNL DAAC. Oak Ridge DAAC is a biogeochemical dynamics data center. We're one of NASA's Earth Observing System Data and Information System Data Centers, EOSDIS, managed by the Earth Science Data and Information System, known as the EOSDIS project. The EOSDIS project is responsible for providing users with access to data from NASA's Earth science missions. Specifically, the mission of the ORNL DAAC is to assemble, distribute, and provide data services for a comprehensive archive of terrestrial biogeochemistry and ecological dynamics observations and models to facilitate research, education, decision-making in support of NASA's Earth science. So to say that in a nutshell, ORNL DAAC archives data products for NASA's terrestrial ecology program in support of NASA's carbon cycle and ecosystems focus area. And you'll see my URL, or the data center's URL there at the bottom of the page. Moving on to the next slide, I want to tell you just a little bit about how we organize our data products and services at Oak Ridge DAAC. The biogeochemical and ecological data products and services are organized by project and categorized into 4 primary groups. Those 4 groups are field campaigns, land validation, regional and global data, and model archive. Field campaign data sets are ground, aircraft, and satellite-based measurements of biogeochemical features in specific ecosystems over multi-year time periods. An example of that would be the North American Carbon Program, abbreviated as NACP. Land validation data products are comprehensive collections of assessments of ground-based observations coincident with satellite data that are useful for developing, calibrating, and validating ecosystem models. An example of that would be our FluxNet project. FluxNet is a network, a network of micrometeorological towers who use ED covariance measurements. Our regional and global data collections are for understanding the structure and function of various ecosystems across multiple spatial and temporal scales. Examples of that would be soils or vegetation. And our model archive has a couple of different tiers. One of those tiers encompasses code from benchmark model versions. And the second tier then is associated with published research results from specific model implementations. And one example of that would be EDM, Ecosystem Dynamics Models. There's a version for both North America and South America. So in a nutshell, we have 4 categories, about 30 projects, and more than 1,100 data products. To tell you just a little bit more about our tools and services, we provide tools and services to help researchers readily find and access our data products. These tools have features such as search, visualization, subsetting, and analysis capabilities. The URL there is to the list of tools that we have available. The focus of this webinar is going to be on the MODIS Global Subsetting and Visualization tool. The purpose of this tool is to allow users to order MODIS land product subsets for any site, area, or time period globally. It provides both point and gridded data, visualization, subsetting, and service capabilities. And the goal of this tool is to help users to deal with large data volume, accessibility issues, complex data formats, and processing time. And you see at the bottom of the page the URL for the MODIS Global tool. So just to talk specifically about the tool and the two versions of the tool that we're about to demonstrate to you, I'm sure that you all know that MODIS data is moderate resolution imaging spectroradiometer, which is a hyperspectral sensor on board 2 satellites, the Terra and the Aqua satellite. These 2 satellites view the entire Earth's surface every 1 to 2 days, acquiring data in 36 spectral bands or groups of wavelengths. The MODIS Global Subsetting and Visualization tool is available in a GUI and in a web service. The GUI allows you to have site selection from a pick list or by entering the site's geographic coordinates. The area defining the site can be from 1 pixel up to 201 by 201 kilometers. The data are available for any time period. The web service is identical to the GUI except that it allows you to programmatically obtain MODIS subsets for any land location, time period, or area using Simple Object Access Protocol Web Service, or SOAP. Okay, just to tell you a little bit about the two tools, the output that you can get from the 2 tools. The output available is time series plots of the selected product measurement, and I've given you a URL with the complete products list there. You get an ASCII file of the pixel values for the selected product along with quality information. There are average and standard deviations for the area that you select. There's a file that can be imported directly into GIS software, a land cover grid showing the IGBP classification of the area, an estimate of heterogeneity, that's the Shannon richness and evenness, MODIS phonology time series, and documentation, which includes the QC filter conditions. So in order to run the MODIS Global Subsetting and Visualization tool, there are 6 simple steps, and I'm going to go over these verbally, and then Suresh will show you this shortly in our demo. So the first step is to select the location, and you'll press Continue. The second step is to select the desired data layer and the subset size, and you'll continue to select the temporal range, provide an email address, and press Continue. So at this point, you're at step 4, where you receive an order description and a button which says Create Subset. Once you press the Create Subset button, you will see an order summary and verification. That order summary shows you where your order is in the queue and gives you a record of exactly what you've ordered. As soon as that order processes, you will receive an order notification and data retrieval instructions within an email which contains a unique URL for each order.
The conference is now in talk mode. The conference is now in silent mode. The conference is now in talk mode. The conference is now in silent mode.
Tammy, you need to unmute yourself, *6.
Can you hear me?
Yes, I can. There was feedback. Participants, if you could please be sure that your phones are muted, that would be fantastic. Thank you so much.
I'm not quite sure.
Pardon me for the interruption.
I'm not quite sure which slide that you lost me on.
I think if you get back to step 4, Tammy, that would be great. Thank you.
Okay. So we're going to continue from step 4, At this point, you have already selected your location, your data layer, your subset size, the temporal range, and provided an email address. Step 4 is an order description, and this is the point at which you actually press the Create Subset button. Once you've pushed the Create Subset button, you receive a visual order summary and verification. This tells you where your order is within the queue for processing. Once your order has completed, you will be notified via email with a unique URL for the order you've just placed. Inside that email message, when you click on the URL, your visualization has interactive scroll bars and optional display features. It facilitates data download and provides an interface for ordering different land products for the same location. So, at this point, I want to tell you just a little bit more about the MODIS Global Subsetting and Visualization Web Service. As I said before, this is done through a SOAP web interface. An example of that is from the command line, you would type something like get products, open paren, close paren. And from command line, that would return to you a list of the available products. What this web service allows you to do is to retrieve subsets through command line operations. It allows you to get subsets directly into software such as Kempler and MATLAB. And it will also provide a mechanism by which you can integrate these subsets into client-side workflows. It will also allow you to write custom code to use the subsets for visualization and for reformatting. On our website, in the URL you see here at the bottom of the page, we have several client and application examples. We have client examples for Java, Perl, and Python, and code examples for Kempler, R, and MATLAB. So this next slide gives you some points of contact here at the ORNL DAAC. The first one is our User Services Office. The second is Suresh Vanan, our ORNL DAAC manager, who will be speaking shortly, myself, and our Chief Scientist, Bob Cook. Before I finish here with this last slide, I want to tell you that if you download the slide deck, after the presentation, there's a section called Additional Slides. In the Additional Slides section, each of the steps for placing an order is displayed using screenshots. And following that are a bunch of screenshots explaining to you exactly what the output is and what it means. Thank you very much for your attention.
Okay, we will now switch from the PowerPoint to the live demonstration portion of the webinar. Okay, our next speaker is Suresh Vanan, who is the Oak Ridge DAAC manager.
The conference is now in talk mode. The conference is now in silent mode.
Hello. Can you hear me? Hi, my name is Suresh Vanan. As Jennifer introduced, I'm the ORNL DAAC manager, but I'll be giving this demo in the capacity as the lead developer for the MODIS Land Product Subsets tool of the Oak Ridge National Laboratory DAAC. So The goal for the demo is to introduce the MODIS land product subsets tool for our users who are not familiar with it. But as we go through the demo, we'll also introduce some of the advanced features, but also make sure to introduce the next version of the MODIS land product subsets as well. As Jennifer and Tammy mentioned, this is a two-part demo. The first part of the demo would be focused on the MODIS global tool, and the second part of the demo would be focused on the MODIS web service. So to begin with, I would like to present the MODIS land product subsets web page, which describes about the various tools that we have to obtain subsets of the MODIS land products data. The website also has several information about the processing methodology, the data products, and the citation policy information, and so forth. But what we also provide is a set of classroom exercises for some of our participants who may be in the educational industry, as part of using remote sensing as part of classroom education. So there's several information which is available, and I probably wanted to showcase this web page, which has a rich documentation that would be useful for our users who've been using the subsets from the DAAC. The second page over here is the MODIS methods web page, which describes the processing methodology for our subsets. So this web page gives you all the information about how we create these subsets, and also the information about each of the data products which are offered, and the data formats of the files, and projection information, and so forth. So I just wanted to point this rich documentation source for our users. This is available from all the orders under the header information. And as you can see when I mouse over, this header is embedded with all the orders that are delivered, and you would also find this on the website as well. So that's with regards to getting more information about the MODIS land product subsets tool. Moving on, the first tool that we're going to talk about is the MODIS global tool. As Tammy mentioned, there are 6 steps to ordering a data product from this tool. The very first step is to basically select the location for which you need to obtain the data. And in this case, I have a pre-populated latitude, longitude for a location in Southern California. If you want to change the location, you can type into the box, and the Google Maps window would zoom into that location automatically. The second option to select a location is to pick some pre-selected sites. So on the right of this page is a list of pre-selected sites that we store in our database. And these sites are field sites, which could be flux tower locations. These could be Aeronet sites. These could be general validation sites which are used by the community. So we have a database of more than 1,000 sites that we've compiled in this interface. So for the purpose of the demo, we would be using the latitude, longitude that I've populated in this box. So clicking continue, you see a list of all the data products that are offered. These data products, I just wanted to point out 2 critical information for our users who are not too familiar with the MODIS data products. The first critical information is these IDs. So you see these IDs say, on the one that's highlighted, it says MOD 11A2. That's just an ID that NASA uses, which represents the land surface temperature and emissivity data product. If you see MOD, it means that it came from the Terra satellite. And if you see MYD 11A2, then it means that it came from the Aqua satellite. This is just a naming scheme that's being used by NASA to identify each of the data products. For the purpose of the demo, we would be doing the vegetation indices product. The other critical information is the compositing of the data. All the products which are offered by this tool is available is in a temporal and a spatial compositing format. What I mean by that is when I say temporal compositing, several dates of data are taken in and composited to basically get the best data value for that time period. For example, for the land surface temperature, it is an 8-day temporal composite. It means that the average temperature of all the good pixels are taken into consideration to come up with a single land surface temperature value for that particular time period. The spatial compositing means that you have to, it basically takes the sinusoidal projection of the MODIS land products, and then it grids it into a 1 kilometer, 250 meter, or a 500 meter data product. So every pixel has uniform spatial resolution. So there's some spectral and temporal compositing of the data that's done. So this is important as you're doing some specific scientific analysis on the data. So we will pick the defaults for this demo and move right along. So this is a fairly simple selection of the start and the ending time period. One critical information to note over here is this ability to obtain the geotiff subsets. So the geotiff subsets by default are provided in the MODIS sinusoidal projection, but several of our users have a need for the data in geographic projection, especially if you're using in a GIS format. So moving along, you need to supply your email address. And when you hit continue, it's going to give you all the information about the data product that you've requested. And after you hit create subset, the order has been placed in the queue. I know several of the attendees on the webinar today have used our tool before. Several of them have used it more than once. So this may be repetitive, but for the participants who have not placed orders through this, this might actually be useful to walk them through. So once after the order has been received, an email would be generated, and the email would contain a link to a URL. The URL has the subset information, all the data, and the visualization for that particular order. So this is the order page for that location for which we created the subset. And I'll walk through the individual visualizations and kind of explain each one of them. So the first thing to look at is this time series plot. The green bars at the bottom indicate the percentage of pixels which pass the quality flag. We do have a URL which indicates, which kind of walks you through how the quality information is used from within the MODIS land products to extract just the good quality pixels. The blue dots that you see on this time series are the value of the center pixel. The red is the average of all the good pixels within that subset area. And then the gray bars that you see are the standard deviation information. The time series on the left shows all the good pixels within that subset area, irrespective of the land cover class. The time series on the right, I've highlighted one example, are the good pixels of the land cover that matches the land cover of the center pixel. So in this case, the value of the center pixel is a woody savanna, and within that subset area, we have about 531 pixels, which match the land cover of the center pixel. So this is really important, especially in terms of applications like forestry, where if you're interested in understanding how does NDVI change only within that forest, this time series would be very useful. So in this case, nearly 85% of the land cover matches the center pixel, so you don't see a big difference between the two time series. In other cases, this might act in very heterogeneous land cover. This might be quite important. The second time series is more of a hands-on time series, and I'm showing you the ability to scroll through within the time series. So we use Google visualization to render these time series where the users have the ability to zoom in within a smaller section of the time series. And then as you mouse over the chart, the values would be displayed right within the charting interface. So scrolling down, you see a list of all the data products available. And these data products, we offer primarily three main data products. The subsets are primarily delivered in a CSV format, which users can incorporate into their spreadsheet software. Like you can use it in Excel or statistical software like R or SAS or MATLAB and so forth. The statistics data is primarily useful to conduct scientific analysis where you don't have to have all the pixel values, but you're interested in just the statistical information such as the area, the mean, maximum, median, and so forth. The GIS information are also delivered, and also the land cover data as well. So we also have several visualizations to provide contextual information. You've got the land cover data, and we also have the phenology information. So this is the current state of the MODIS global tool as it stands right now. And the example that we saw, the time series indicated a big jump, a big downward shift in the NDVI pixel values. And the reason being, this subset was created for a fire event in Southern California, which happened in 2009. So as you saw, within about 9 minutes, so this order took about 9 minutes to execute, you were able to see a time series of how the pixels were affected because of this fire event. So moving on, we wanted to give you a sneak peek of the next version of the MODIS global tool. So this is the interface, and without having to go through the ordering, we've simplified the number of clicks rather than going through 6 steps. Now in 4 steps you can place the orders. So a couple of steps have been minimized, and we've also updated the interface with some latest packages. So here is a sneak peek of the ordering interface in the next version. There are 2 critical changes that we are aiming to implement. The first one is this ability to provide subsets of daily products. So as I mentioned early on, we provide subsets of 8-day, 16-day temporal composited data, but we're looking at providing subsets for daily data, primarily the daily surface reflectance data. So as you see that the amount of data would be enormous. The second major change is we're increasing the size of the subset. We're moving to a 200 by 200 kilometers to 1,000 by 1,000 kilometers. So those are 2 major changes that are coming about and which would be implemented within the next 6 months or so. But here's the interface where we've cleaned up how all the different information are presented. So it's got tabbed format. Users would also have the ability to download the data through an FTP web service rather than HTTP. This allows more flexibility and in ease of download. The second key changes is improvements in the visualizations. So in this example, you see that we've got a slider where you can change the visualization dynamically, and you can also stack the time series plots. I can show you how the pixel have, although there was a big fire event in 2009, the overall pixels did have an impact. So 2009 has the lowest NDVI value amongst amongst all the other years as well. So a few other major changes are we are integrating R plots. So a lot of these codes can be executed right from within the interface. So users can download the data and incorporate that data directly within R. And these graphics that you see have been rendered automatically from the subsetted data. These visualizations and the R code will be available to our users. And what we are hoping will happen is the advanced users would be able to take this and add more processing capability and provide that code back to us for the benefit of the broader audience. So the other main feature that I wanted to point out is the ability to visualize individual composite period. So the way I got to that page was to use this tool set, visualize individual composite dates right at the top of the order URL. So you can visualize individual dates within it, and you can see the subset data values. And there is also a legend which describes as to how this displays. I do want to show the image from NASA, which shows the fire event. This is a screenshot. This is a browse image from the MODIS Rapid Response website, which shows the fire event around the time period of that, which shows why we had this big dip in the NDVI. So moving on from the MODIS Global Tool, we want to step into the MODIS Web Service. The MODIS Web Service provides the ability for our users to obtain the subsets using command line. So in the Global Tool, it's all web interface. You have to click through several web pages before you get to the data. So we can obtain the subsets directly from within the command line using the MODIS Web Service. And because the web service is based on a standard, several tools can incorporate them without having to understand a whole lot of programming behind how this functions. And I'll explain this really shortly. So there are several functions which are available within the web service. So there's get products, get bands, get dates, get subset, and get subset order. The two key functions are get subset and get subset order. The get subset provides you the subset for any particular time period and the subsets area using this function. The users, if they have a SOAP-based web service, they can incorporate this function in their program. I'll show you a quick example so it becomes a little bit more clearer. The subset order function allows the users to order the visualizations without having to go through multiple clicks. This is primarily useful if you have, let's say, 1,000 sites for which you want to create these time series graphs. You don't have to click through the website 1,000 times. If it's 6 pages, then it means like it's 6,000 clicks. You can use this script to order that data product and place these orders through command line. We have several examples. Many of these were contributed by our users. And examples of these code are starting points for you to incorporate the MODIS Web Service. I'll walk through one example, one application of how this web service would be useful, and I'll also give a few examples of application areas for these web service. Web service is an old concept, but it's still fairly intimidating for folks who've not used it. But to be very honest, it's very straightforward. You really let the scripts and the programming language do the heavy lifting. So our goal with providing these examples were to get you started on. So here's an example of the MODIS web service Perl script. This example, as you see, is just about 20 lines. It provides you with the MODIS subset for a particular location. In this case, the location is 40 degrees latitude minus 100 degrees west. Mod 11A2 is the data product. And then the rest of the information are the bands, time period, and spatial extent. So I have a screenshot of how this would execute. But in this example, rather than using land surface temperature, I've used MODIS land cover as my data product. So in this case, by using the same script, but instead of the land surface temperature, I'm saying, give me the MODIS land cover for this particular latitude, longitude. And when I execute it, it gives me back a number. The number is 8, and 8 maps to woody savannas. So if you're doing land validation out in the field, you can have a small script which would access a server and get the latest land cover information right from within the field without having to download several information. So that ends the demo. As you saw, we tried to cover a wide gamut of from beginner level to advanced level. The goal of the demo was not to give a comprehensive or overview of the tool, but to introduce some of the advanced concepts, but also give some basic information. We would be happy to take questions, and if you have any specific queries about the tool, we can get them addressed through email as well. But I'll turn this over to Jennifer.
Okay. So why don't I, so right here we've got a few polls. If you could take a couple of minutes to address those polls, we would greatly appreciate that. And after we've done that, I'll give it about 5 minutes or so, we'll take questions. I thought I might throw this idea out there for those of you who may be attending the upcoming Ecological Society of America conference. We will have a NASA booth at the show, and please feel free to stop by the booth to have a one-on-one tutorial for using the MODIS tool. I will be there as well as Tammy, and we can certainly address any range of skill sets in using the tool from beginner through advanced. Suresh will also be at the show. Please keep that in mind. Okay, if there are no further answers for the polls, it looks like it's not moving too much right now. We'll go ahead and move on to the question and answer period. I'll give it just another minute or so. Remember, for the short answer, you will need to click the submit button, which is right here to the right that says send answer, if you have selected other for the new features. Okay, why don't we go ahead and move on to the question and answer period. And I do want to thank all of you for participating in today's webinar. We do have another webinar, the same webinar, to take place tomorrow, and we will use feedback received today to tailor that webinar a bit based upon today's feedback. It's the very same webinar, perhaps with a few tweaks. The event, again, has been recorded and will be posted at the tinyurl.com Earthdata webinar URL that I've included below. Okay? The files for today's presentation are located for download in the lower right-hand corner, both the agenda as well as the PowerPoint presentation. Okay, so why don't we go ahead and, can everybody hear me okay? Let me try to unmute all and see if there's not any feedback. We may be able to answer questions that way.
The conference is now in talk mode.
Yes, you're coming through fine.
Fortunately, there's a lot of feedback, so I'll have to mute all, and we'll take the questions. We'll answer them verbally, okay? So Suresh and Tammy, you'll need to unmute yourselves in a moment, okay?
The conference is now in silent mode.
Okay, so let's go ahead and take a look at these. What we've got so far. Okay, the first question, I don't know this individual's first name, so are the data retrieved from the, it looks like they're referring to the FTP site for LP DAAC. So Suresh or Tammy, make sure you're unmuted.
Yes, the data are from LP DAAC. LP DAAC is a sister DAAC to us, so as and when new data products become available, they send that information over to us. So we are collaborating with LP DAAC to expand the suite of data products which can be available through the subsetting tool.
Okay, so I've just included the link to the LP DAAC website. They do have a MODIS data table that would describe more information about all of the MODIS data products, for example, as well as processing levels, quality, flags, etc. So for those of you who may not be, who may be beginners or intermediate and are interested in that information. The next question is, can we extract information from MODIS 13, but from several states in the same query? So I'm not sure if I understand that question right. If I were to interpret, I would say that you're asking whether or not we can extract information from several geographic locations within the same query. Would that be your interpretation, Suresh and Tammy?
Yes.
And for the individual who asked the question, if you'd like to respond using the question and answer pod, that would be fantastic too, if I've interpreted that accurately.
So there's two interpretations that I have on this, Jennifer. The first one is, can we have multiple latitude, longitude, or subsets for the same order? The answer is no to that. The subsets have to be created for each subset location separately. The second interpretation that I, for this question is, can you do subsets for polygonal area and for several of them? Like, say you have several counties or estates for which you want to obtain these subsets. Right now, the subsets are rectangular or square regions. We are exploring the ability to do a cookie cutout of polygonal area, but we want to do that as a workflow. So we would provide a set of workflows to the users and then they can execute that workflow at their end. So let's say they have these information about their area, they can include that in that subsetting workflow and generate the subsets. You can, however, automate obtaining the subsets for several locations using the web service. We have some examples on the website as well. So you can automate obtaining the subsets for several locations.
Okay, great. Thank you, Suresh. The next question is coming from Z Yang. Is there any plan for collaboration with earthengine.google.com? Many MODIS products are also available on there.
I don't know the answer to that. Right now, we are not collaborating directly with Earth Engine, but perhaps at EOSDIS there may be some connections. Primarily on this tool, there's really no direct linkage to Earth Engine.
Okay, thank you. The next question is coming from Jody Norris, and she is asking about methodology for phenology metrics.
Okay, the phenology data, the graphics that's provided as part of the subsets are created from the MODIS product, and the ID for that is MCD12Q2. It's a phenology data product, and it's available for 10 years or so, I think starting from 2001, about 10 years. And the data is provided in two cycles. So it assumes that there are two phenology cycles within a year, and for each of the cycles, it provides the start dates. It provides the dates for which you see an increase in phenology, and when a maximum phenology has been attained, and when it starts to fall down. So we use this information to render the graphics. Of course, we look at the quality flags, we eliminate water pixels, and we eliminate any data which has been, which doesn't fall under our quality criteria, and we just display the values for the good quality pixels. There is a detailed document which explains the algorithm behind the processing of this phenology data product. So I think if you do a Google search on MODIS phenology algorithm, I'm sure you would be able to find a more detailed description about the exact science behind obtaining the phenology. But it's using data for several years to come up with the phenology metrics.
Okay, and moving on to the next question. And Suresh, do I have that correct? It's the MCDQ2 is the short name for that product.
That is correct.
Okay, moving on to the next questions. Are there plans to include MODIS ocean data in the future?
Not in this tool. The MODIS ocean data is available from EOSDIS, and I think DAAC, another sister DAAC, they have all the data products. They do have subsetting capabilities. The types of visualization and subsetting is slightly different for ocean applications. So right now we don't have plans to include ocean data products. So as Tammy mentioned earlier on, we are a terrestrial biogeochemistry data center, and most of our focus have been on land areas. But I think there are tools and services with similar capabilities available from DAAC. So you may be able to find similar tools and services from them.
Yes, and I just wanted to, for Mr. or Ms. Montes, mention that first, if you go to the tiny URL that I have listed to the left, I have a Giovanni webinar from last month. The Giovanni tool is an online data access and visualization tool, and they do have a MODIS Ocean Color portal. if you are looking for that particular type of data. So you may be interested to check that out, and of course, feel free to email separately, and I can provide you with information to their user services and some of those resources. Okay, so why don't we move on to the next question. Is there any forecast, thank you for the compliment, is there any forecast to increase subsetting dimension?
The plan is to release the increase in subset dimension with MODIS Collection 6. Collection 6 is a reprocessing campaign at NASA where they're going to go in and reprocess the previous data with the latest and greatest algorithms. And the plan for that is it's going to start sometime in fall 2013. And we are planning to release this next version of the subsetting tool along with the Collection 6 data product. But so depending upon, right now the data is going to be fall. So I would say that early next year you can expect to see this next version of the global tool released to the general public. We are planning to do this release in a phased manner. We get a lot of usage of this tool, so rather than going full-fledged, we want to do a phased approach where we would double the subset size increase from 200 by 200 to 500 by 500. And then if everything looks okay, we are able to deliver, our systems are able to handle the load and so forth. In 6 months or so, our plan is to move towards 1,000 by 1,000. So that's the plan right now. It is in flux, but I don't think, I would say, plus or minus 4 months, but that's where it is. It is open. If somebody is interested in testing it, we can make that URL available, but it is in beta testing mode right now.
Okay, the next question, thank you, Suresh. The next question is coming from Yiwa Wu, who is asking whether or not this data set is real time.
No, these data are not real time. LANS at EOSDIS provides several near real-time data products. The algorithms and the processing behind the real-time data products are different from the traditional data products. The algorithms are by design built to process things quickly, but there are several data products which are available from LANS, and Jennifer can tell what the acronym is for that, but so LANS would actually provide you a lot of this near real-time data specifically for applications. This data, like I said, is temporal and spatially composited. So there is a time lag. For example, with the MODIS land cover data product, there could be almost a year time lag. With the surface reflectance product, which is an 8-day composite, there's about a 2-week time lag because the observations for about 8 days have to be accumulated before you could process that data. But you do have sources to get that, and it looks like Jennifer has posted the link to the LANS website.
Yes. Okay, moving on to the next question from Thomas Milliman. I hope I pronounced that correctly. Is there a procedure for getting project-specific subsets set up in your database?
Yes, we didn't get to talk about the MODIS fixed site subsets in our demonstration today, but we do have pre-created subsets for field sites, and we are going to open it up for beyond field sites. If you've got, let's say, 10, 20 sites for which you're doing some, let's say you're doing soil measurements, you're doing some LAI verification, and you want to get ongoing subsets for that particular location, we would be able to facilitate it. But that again, the plan for that implementation is going to be in MODIS Collection 6. For the time being, you could use the MODIS web service to address that need in the short term. The MODIS web service would provide you the ability to obtain the subsets both from the global tool, but if you just want the raw values, you can obtain that as well. So there are multiple avenues to obtain it.
Okay, fantastic. Let's move on to the next question. Okay, so that was just a thank you. I don't see any further questions unless there are any that we have missed. I apologize for the... All right, well, thank you so much for participating in today's webinar. Again, I do plan to send a link out to those of you who are here today and to those of your colleagues who were perhaps unable to attend due to the registration being full. So thanks again. And if there are no further questions, then we will go ahead and end the webinar. Thank you very much, everybody.